Hello and welcome to another edition of Brain Maths. On today's edition, we are going to be looking at another part of matrices, that is the solution of simultaneous equation by using the determinant method. Using the determinant as taught in our previous lessons to get the solution of simultaneous equation is what we are going to be looking at in this lesson. And this method is called the CRAMER'S rule. Any simultaneous equation given to you, if you don't want to use any of the known methods for solving simultaneous equation, you can as well try to solve it using the CRAMER'S rule. The CRAMER'S rule is the simultaneous equation by determinant method as mentioned. How do we get the determinants from this equation that is given to us? So this is to tell us that if we look critically at this question, the one on the left hand side is looking exactly like a 2 by 2 matrix. And if you look at the other side of the equation, we have a 1 by 2 matrix. So, employing the method of CRAMER'S, it says that for every given equation like this, once you get the determinant of the left hand side, the next thing to do is to find the determinant of P by introducing the constants to where you have your P, and also get the determinants of Q by also introducing the constants to where you have the Q. So let's see how it works. The solution to this problem goes thus. So for question number 1, we have to get the determinant of left hand side. So the determinant in this case is represented by this sign. So we have the determinants of the left hand side to be the values, the given numbers. We have 4, 5, minus 3, and minus 2. So if you solve this diagonally as usual, we have 4 times minus 2, that is going to give us minus 8, minus, since we are getting the determinants, 5 times minus 3, that is going to give us minus 15. So if you solve this out, you have minus 8, minus times minus, plus 15, and that is equals to 7. So we have gotten the determinants of the left hand side. So the next thing is to find the determinants of P. So to get the determinant of P, you are going to eliminate all the values of P. You will not write any of these values. Instead of them, you will bring in the constants to their place. So you are going to be having the constants in place of P. We have 17, 16, then we are still left with minus 3 and minus 2. So if you find the determinants of this, we have 17 times minus 2, that is going to give us minus 34, minus 16 times minus 3, that is another minus 48. So if you expand the bracket, you have minus 34, minus times minus, plus 48. And minus 34 plus 48 will give us plus 14. So we can just write our 14. So the next thing is to find the determinants of Q. So what we are going to be doing now is to eliminate all these values of Q and replace them with the constants. So the determinant of Q is equal to, these ones will not be written again. We have 4, 5, then we bring in the constants in the place of Q, 17 and 16. So solving this diagonally, you will observe that I did not put the negatives in front of the 17 and the 16. That is because these values here are the owners of the negative signs, while the one replacing them are positive. So we don't need to introduce the negative signs again. So we have 4 times 16, that's going to give us 64, minus 5 times 17, that is 85. And when you solve this out, we're going to have minus 21. So we've gotten the determinants of the left-hand side, determinants of P, determinants of Q. So the next thing is to find the value of P and Q. So our P now, P will be the change in P. That is the determinants of P over the general determinant. And the determinants of P is 14, while this is 7. So the value of our P is 2. 14 divided by 7. And the value of our Q now will be the determinants of Q over the general determinant, which is going to give us the determinants of Q is minus 21, and the general value is 7. So we have the value of Q to be minus 3. So using the CRAMER'S rule, the final answer is going to be P equals 2 and Q equals 3. So let's use the same method that we've just employed now to solve question number 2 and see what we are going to get off from that. So question number 2 now says, following the lay down rule, solving for the left hand side, the general determinant equals, the values here are 10, 7, 5, 8. So the determinant of this is going to give us 10 times 8, 80, minus 35. And our answer for that is going to be 45. So the next thing is to find the determinants of x. The determinant of x. So to get the determinants of x, we are going to do away with the values of x and then replace them with the constants outside. So we have 14, change in x. So we have 14, 16, 7, and 8. So we have 14 times 8. 14 times 8, that is 2, 112, minus 16 times 7, 2, and 112. So 112 minus 112 will give us 0. So the determinant of y is the next thing. Change in y equals, so we do away with the values of y and replace them also with the constants. So we have 10, 5, 14, 16. So if you multiply this to 10 times 16, that is going to give you 160 minus, and 5 times 14, that is going to be 20, 5 times 1, 70. So 160 minus 70 will give us 90. So the value for the change in x is 0. The change in y is 90. So the next thing is to find the values of x and also the values of y. So our x is going to be change in x by general change, which is 0 divided by 45, and that is undefined, it is going to give us 0. And y is going to be change in y by general change, which is change in y is 90, and the general one is 45. So that is going to give us 2. So the value of our x is 0, while the value of our y is 2. I'm going to be leaving you with this question on the board. Try to solve the question using the CRAMER'S rule. Get the values of your x and y and leave your answer in the comment section. Don't forget to like this page and subscribe to the channel if you have not done so. Help us to share this video to as many places as possible. Until I come your way again next time, do have a blessed day.